Hello everyone, we are going to see about eigenvalues and eigenvectors of the given matrix. Before that, we have seen about some applications used in engineering students. We have used principal component analysis, machine learning algorithms, recommendation systems, image processing and computer vision, graph and network analysis, deep learning, data compression, clustering and pattern recognition. These are main usages for eigenvalues and eigenvectors, especially for artificial intelligence students. Now we have seen about the characteristic equation. The characteristic equation is mathematically called A minus lambda I, which is equal to 0, which means determinant A minus lambda I is equal to 0. We have some problems of to find the characteristic equation. Given matrix A is equal to 3, 1, 0, 2. The characteristic equation is of the form lambda square minus S1 lambda plus S2 is equal to 0. This is for only 2 by 2 matrix. What is S1 means? S1 is sum of the main diagonal elements and S2 is determinant of A. After finding S1 and S2, substitute those values in the characteristic polynomial equation. Will get the characteristic equation. We have 3 by 3 system of equations now. The characteristic equation is of the form lambda cube minus S1 lambda square plus S2 lambda minus S3 is equal to 0. Now we are going to see about diagonalization of a matrix using orthogonal transformation. In this diagonalization matrix, we have only symmetric matrix. We have to check whether the matrix is symmetric or not. In orthogonal transformation, the given matrix should be in the form of symmetric. We have step 1. Step 1 is given matrix is symmetric or not. If the rows and columns are equal means that matrix is called symmetric. So our problem is called symmetric. Secondary, to find the characteristic equation. And 3 by 3 matrix, we have lambda cube minus S1 lambda square plus S2 lambda minus S3 is equal to 0. Now we have to find the values of S1, S2 and S3. After that, find the eigenvalues. How to find the eigenvalues now? Use synthetic division method or by using calculator. We have to get the values of lambda 1, lambda 2 and lambda 3. Here, check whether 3 lambdas are equal or unequal. If 3 lambdas are equal means we have 3 cases to find the eigenvectors. For lambda 1 is equal to minus 2, use cross rule multiplication method. For lambda is equal to 1 by using substitute method. Again, lambda 3 is equal to 1 means by using LMN method for symmetric matrix. Step 4, to find the eigenvectors. To find the eigenvectors means substitute. We have 3 cases. Lambda is equal to minus 2 means we have 3 system of equations. In 3 system of equations are in different mode now. By using cross rule multiplication method, after by using cross rule multiplication method, we'll get the values of capital X1 like minus 1, 1 and 1. We have case 2. Put lambda is equal to 1. We get 3 system of equations. Here 3 equations. See, 3 equations. In this 3 equations are same means by using substitute method. Either substitute x1 0 or x2 0 or x3 0. Likewise, we get capital X2 is equal to 0, 1, minus 1. How to find the third eigenvector now? By using LMN method. For this, we have to check whether orthogonal to x1 and x2. So for x1 matrices, already we know x1 and x2 vectors. From x1, we'll get minus L plus M plus N is equal to 0. From x2, we'll get 0L plus M minus N is equal to 0. Those two equations will get multiplication of x3. After that, by using cross rule multiplication method, find the value of x3. Now we get the values of x1, x2 and x3. Now the eigenvector matrix are likewise column wise. First column is known as x1, second column is x2, third column is x3. After that, step 5. Form the normalized matrix capital N and normalized matrix transpose. How to find the normalized matrices? From column 1, we have three elements minus 1, 1, 1. How to get the normalized matrix means from column 1, minus 1 divided by root of other elements the whole square. We have three elements, right? Minus 1, 1, 1. So root of minus 1 square plus 1 square plus 1 square. Then second element, how to get the second element of column 2 is, that is column 1 second element is 1 by same root of minus 1 square plus 1 square plus 1 square. Third one is similarly 1 by root of minus 1 square plus 1 square plus 1 square. Similarly, to find the value of column 2 and column 3. Now we'll get the value of n is equal to minus 1 by root 3, 0, 2 by root 6, 1 by root 3, 1 by root 2, 1 by root 6, 1 by root 3 minus 1 by root 2, 1 by root 6. Now write the value of n transpose. N transpose is nothing but transpose of the normalized matrix. Then step 6, find the value of an. Already we know the value of A, that is given matrix. N is normalized matrix. Just multiplication with A and N. So finally we'll get An value is 2 by root 3, 0, 2 by root 6. Minus 2 by root 3, minus 1 by root 2, 1 by root 6. Minus 2 by root 3, minus 1 by root 2, 1 by root 6. Then step 7, capital D is equal to n transpose An. This n transpose An is called normalized matrix, given matrix and normalized matrix transpose. Those three multiplication will be the diagonalization of the matrix. Finally, diagonalization of the matrix should be the eigenvalues of the given matrix. We have n transpose value is minus 1 by root 3, 1 by root 3, 1 by root 3. Second row becomes 0, 1 by root 3, 1 by minus 1 by root 2. Third row becomes 2 by root 6, 1 by root 6, 1 by root 6, which is multiplied with A into capital N. A into capital N is 2 by root 3, 0, 2 by root 6, minus 2 by root 3, 1 by root 2, 1 by root 6, and minus 2 by root 3, minus 1 by root 2, 1 by root 6. After getting n transpose and an, multiplication with n transpose with an. So n transpose value and an value will be minus 2, 0, 0, 0, 1, 0, 0, 0, 1. This is the formation of diagonalization. Finally, we will get the diagonalization matrix is in the form of lower triangular and upper triangular form. So lower triangular, upper triangular form means finally we get the diagonal elements only. The diagonal elements should be in the eigenvalues of the given matrix. Go to with second question. Diagonalize the matrix capital A is equal to 1 minus 1 minus 1 minus 1 1 minus 1 minus 1 minus 1 1. We have again 3 by 3 matrix. Now we have to check whether this matrix is symmetric or non-symmetric. If it is non-symmetric means the procedure is wrong. If it is symmetric means proceed the same. For step 1 like the matrix is symmetric. Step 2, like the matrices to find the characteristic equation. Third step is to find the eigenvalues. Fourth step to find the eigenvectors. Fifth step to find the normalized matrix, which is called as N. Sixth step is to find the normalized matrix transpose, which is called as N transpose. Sixth step is to find the value of A into N. A into N is nothing but given matrix and normalized transpose. And finally, the diagonalization should be N transpose into AN. N transposes normalized matrix transpose. A is given matrix and N is normalized matrix. Then N transpose, already we know the value of N transpose. We know the value of A into N. Then multiply with N transpose and AN will get the diagonal matrix. Here diagonal matrix should be in the form of upper and lower triangular. Will get only the diagonal elements. These diagonal elements should be in the form of eigenvalues. This is the diagonalization of the given matrix using orthogonal transformation. Thank you.